This is an introduction, a very basic general introduction to functions. What is a function? Well, a function is any relation in which x is paired with only one y. Let's write that down. A function is a relation in which each x is paired with only one y. All right, well, let's see what that looks like. Here's a function that I'm going to illustrate as a set of points. So I'm just going to put some points up here. F equals, and then I have the point negative 1, 2, 0, 3, 2, 5, 1, negative 4, and 4, 6. So it's just a set of points that I've made up. All right, but this is my function. Is this a function? This is my relation. Is it a function? Well, when you look at the x coordinates of these points, they're all different. This means that I don't even have 2 points with the same x. So each x is paired with only one y. This negative 1 is paired with 2. There's not another point that has negative 1 for an x coordinate, but a different y coordinate. So this does count as a function. All right, well, sometimes we represent relations as curves. So I'm going to draw some pictures of some curves. All right, let's say this one is just a line. Let's say that this one is something that's kind of curvy, like this. And let's say that we have a picture like this. Okay, well, are these functions? The easiest way to tell with a graph whether or not you have a function is to use the vertical line test. Now, the vertical line test means that a vertical line, as I pass it over my curve, should only touch the curve at one point at any given time. And you can see that with my line, my vertical line does in fact only touch the curve in one point as it goes across. So yes, this is a function. Y is a function of x in this graph. All right, well, let's look at this one. As I pass my vertical line across this one, does it touch the curve in more than one point at a time? Well, no, it doesn't. It only crosses the curve in one point at a time. Therefore, this also qualifies as a function. Well, what about this one? Well, it's easy to see that this one touches the curve in 2 points when x is this number, and actually that happens a lot. So, no, one x is paired with 2 different y's, therefore this is not a function. Well, sometimes you have equations that represent your relation. So let's look at some equations and see how we might be able to tell whether or not they are functions. All right, well, let's look at this equation right here. Let's say we have 4x plus y squared equals 9. All right, is this a function? Does it represent a function? Y as a function of x? Well, let's see what happens when I put negative 1 in for y. When I put negative 1 in for y, then I have 4x plus, and then negative 1 squared equals 9. Remember to put your negative 1 in parentheses because you're going to do something to it before you add it to the 4x. All right, well, what is negative 1 squared? Negative 1 squared is 1. So we have 4x plus 1 equals 9. And then I'm going to subtract 1 to move it to the other side. So I have 4x equals 8. And when I divide by 4, then I have x equals 2. So when y is negative 1, x is 2. Or when x is 2, y is negative 1. All right, well, let's put a different number in for y. This time let's put positive 1 in for y and see what happens. All right, so I'm going to put positive 1 in for y. Well, what is 1 squared? Well, 1 squared is 1. So 4x plus 1 equals 9. When I subtract 1, then I get 4x equals 8. Very quickly, you can see that you're going to get the same thing for x that you got over here. So when x is 2, y is either going to be negative 1 or positive 1. Since 1x is paired with 2 different y's, this is not a function. All right, well, what if I have What if I have this equation? Y plus 2 equals the absolute value of x. All right, well this time, since x is doing funny things here, I'm going to pick some numbers for x. And I'm going to see if I can find an x where y would be a different value. All right, well let's put -1 in for x. So we have y plus 2 equals the absolute value of -1. Well, what is the absolute value of -1? Well, the absolute value of -1 is +1. So this is y plus 2 equals 1. And when I subtract 2, then I get y equals -1. So when x is -1, y equals -1. Well, let's put +1 in for x. Y plus 2 equals the absolute value of +1. What's the absolute value of +1? What's 1? So y plus 2 equals 1. When I subtract 2, then I get y equals -1. So you see, when x is -1, I get -1 for y. When x is +1, I get -1 for y. Well, that's okay. It's okay for two different x's to be paired with the same y's. But it's not okay for one x to be paired with two different y's. So this appears to be a function. One more. This is a little hard because it's easy. X equals 6. Is this a function? Well, let's think about what the graph looks like, because we actually do know what this graph looks like. So when I look at what the graph for this equation looks like, I want to know, where is x equal to 6? Well, x is equal to 6. 1, 2, 3, 4, 5, 6. X is equal to 6 here, and it's equal to 6 here, and it's equal to 6 here, and it's equal to 6 here. You see, all of these points have an x coordinate that's 6. And so if I draw this, if I connect these and draw this pattern, then I have a vertical line. Well, does this pass the horizontal line test? I mean the vertical line test? Well, obviously not, because when my line gets to this line, then it's touching in all the points. So this is clearly not a function. So these are some ideas to help you determine at this very early stage whether or not your particular relation represents y as a function of x.